And we're live. It's a little after 7 o'clock, 7:02 by the clock on the wall. And we've got some cool stuff going on tonight. First of all, we're going to talk about turbos because it's like my favorite subject. And not only that, we're going to be talking about this book, My Formula, the Turbo Era of Formula One. And to give credit here, this was done by Alan Henry. Lots of cool stuff in here. Lots of information on how it started with the Renault stuff. Ferrari stuff is in here. The tag Porsche stuff is in here. The Honda stuff, BMW. Lots of cool stuff. What a lot of people don't realize about this, and we'll get into this in just a minute, is that the turbo era, everyone talks about these million horsepower things that they had. But if you take a look at the power outputs and the formulas, they kind of follow together. I mean, and also that they started out at a much lower power level and ran at a much lower power level than everybody talks about. Oh, these things all made 1,000 horsepower in qualifying trim. Lots of them didn't. Some of them did. But they ran at a much lower power level. And sometimes on some of the systems, they had different settings that the driver could choose from. Different settings. And because one of the things that they don't realize and that people never talk about when they bring up this golden era, this turbo era of Formula One racing, is that they don't ever talk about the fuel consumption. Because this is one of the reasons that actually made life difficult for the turbo stuff, is that they kept limiting the fuel. They wanted these guys to run naturally aspirated, especially the Cosworth guys who were basically funded by Ford. And these were all customer motors that they had. And so they got to run 3-liter naturally aspirated V8s, where the turbo guys ran 1.5-liter. They were supposed to be supercharged, but they were turbocharged motors. And then we'll get into the whole discussion on what the difference is between supercharged and turbocharged, and why some of them actually tried compressed supercharging, which was very, very cool. And I'll have to do another video on that later on, maybe when I talk about other different kinds of forced induction, like a Lysholm, like an axial flow, and this compressed deal, because it's kind of complicated. It's really, really interesting, though. But we also want to talk about one of the reasons I wanted to do this live is we wanted to talk about a situation where, and it's a little confusing, because how do you get more power when you have less boost and higher back pressure? How are all of those things related? And so we're going to talk about that tonight. So we got lots of cool stuff going on. I see Tim's here, Uncle Squirrel, who has changed his name. Way to go, John. That's very cool. Stango Niner. Tanny's here, Sirius, Jim, James, Derm, the Ozman, One Media, who's Grant's here. I'm glad all you guys are here, man. This is great. It looks like I've got some good internet reception, at least for now, going on. But the first thing we want to talk about is, like I said, we were talking about a situation where and I'm going to take the camera off actually and show you I can show you the screen, because I've got a graph here. We can kind of show you what's going on. It's fairly interesting. This is a situation where I ran a turbo combination. I'll go ahead and show you this. So you guys can kind of see, hopefully you guys can kind of see this. I'll show you my graph here. So hopefully you guys are seeing that, and I'll kind of zoom in here a little bit. So we're looking at the boost pressure and back pressure on two different situations. One, this is actually, I'm going to do a full video on this, so you guys will get to see all this. But this is a test I ran comparing 317 heads to LS3 heads with predictable results. And we ran this on a turbo combination. Not surprisingly, the LS3 heads make more power NA, and they make more power under boost because they made more power NA. They're going to make more power at any given boost level. But the interesting thing, and if you take a look at these, the LS3 is in red, we see that the LS3 had lower boost pressure, not by a lot. You're talking about, maybe a half pound or so. It had lower boost pressure. It also currently had higher back pressure. You take a look at that, you can see, again, not by a lot, but we were only running, this was only 7.5 pounds at the peak. But the interesting thing is, if you take a look at this, and the reason for that, and this is what we want to discuss tonight, is the boost pressure went down, the back pressure went up, but, and this is the interesting part, the power went up. And actually, I want to talk to you guys about how all of that is related and why it would do that in this situation. So you guys got to see it. Hopefully you guys can all see the. Please let me know. Chime in on the comments. Could you guys see the graph? So the situation is, as I said, we ran a back-to-back head test. I ran 317 heads on this 6.2 liter LS3. We ran it with a cam, and we ran it, and I'll get into all of that in the video. But we ran the 317 heads versus the LS3 heads, and the rec port heads make more power. A rec port head on a 6 liter and up combination, whether it's turbo or NA, makes more power. Those heads flow 315 CFM. The 317 heads flow, I don't know, 230 or 40 or 50, something like that. But it's a lot less than a 317 head. So, or a lot less than the LS3 head. So the LS3 heads make more power. And they did, and then that also, when we ran it, we just ran. I don't think we ran that one with TC1 controller, electronic controller. I think we just ran it with a manual controller, and it made a little bit less boost, but it made more back pressure. It made less boost pressure and more back pressure, and the reason that it did that is because it made more power. And, there's more flow going in, obviously. And if we had an air meter on this, we could see that, because we could see, the dyno tells us what was happening. It basically made more power, and it made more power despite the fact that it had about a half a pound less boost. And the fact that it made more power is the reason that the back pressure was higher. And that's what a lot of people don't realize. And that's what I wanted to talk about tonight, is that immediately, if you were to look at that graph, you say, oh, yeah, the boost pressure is lower and the back pressure is higher, that's going to make less power. But you have to look at it the other way. So we look at the power curve and go, oh, okay, it made at the same boost or a little bit lower boost, it made more power. Forget about the boost pressure and back pressure curves for a minute. Okay, the LS3 headed combination made more power. So what happens when a motor makes more power? Well, when it makes more power, it has more air going in, but it also has more air coming out. It has more exhaust coming out. So all of that exhaust, when it's confined by a turbo, which is usually the restrictive part of the combination, when it's restricted by the turbo, you're going to increase back pressure, because now you have more exhaust trying to get out of basically the same orifice. In this case, it's the hot side of the turbo. So the back pressure will go up. And because the back pressure went up, the boost pressure went down, and the power went up. And that's how they're all interrelated, because we freed up the system. It would be the same as if we put a camshaft in it. But anything that you do to increase the power output of the naturally aspirated motor is then going to make more power under boost. It's then going to generate more exhaust. And then usually what happens is the back pressure will go up, because now you're asking the system to flow more exhaust from that increased power level. So all of that should make sense. But it's weird, because a lot of us look at it, and I've done it before too, a lot of us would look at it depends on what curve we looked at first. So we looked at the boost pressure and back pressure curve. We'd go, oh, look, yeah, that one's got to be it's making less boost and more back pressure. Both of those are not good. So it must be making less power. But when we look at the power curve and go, it's making more power, now that tells us why these other curves are the way that they are. And if we turn the boost up, we would just have more back pressure, and then we would get to a point eventually with that turbo where we'd have more back pressure than we want, probably. And ultimately on that turbo, and I'll have to, when I do the video on it, I'll have to talk to you about what the specs are on the turbo and stuff. But ultimately, that one would probably be restrictive on the hot side of the turbo, which is not uncommon. I know that I got some comments on some stuff from a guy asking, and I think that it was, Celica, Tom Celica, asking why a specific turbo made more power on a 2J motor than it did on an LS. And the reason is just what I covered. Typically what happens is, if you can't get to the maximum flow of the compressor, and also this has something to do with what we got last night with our compressor maps, if you can't get to the maximum flow, the absolute flow limit of the compressor, and you reach the flow limit of the turbine side before you get to the flow limit of the compressor side, going to a smaller motor, and even if you have to run more boost to make this happen, as long as there's room on the map to go up on the compressor map, assuming we had a compressor map, but a smaller motor will have less back pressure. it will produce less back pressure. So the lower back pressure, because it starts out lower and it ends lower on a smaller motor. So the 2J can take advantage of, it has enough exhaust flow to take advantage of what the compressor has to offer, so it can get everything out of the compressor from that turbo that the LS wasn't able to do. And we see this going from a 4.8 to a 5.3 to a 6.0. And we saw that to some extent when I did the testing. If you take a look at the video that I have up on the GT45 clone turbo, the low buck turbo that I run on everything, if you take a look at that, we can get more power out of that on a 4.8 than we can on a 6.0 or a 454 is another example, because I used that turbo also on a 454. We also ran it on a Honda, and more than likely on the K-Series Honda with that GT45 clone, we probably would be able to get more power out of that turbo on the little Honda motor than we would out of the even 4.8 liter LS. But the smaller the motor, the more able we are to use everything that's there with the turbo. And this is fairly common. It just takes, it takes a lot more boost, because we're starting out with a 2J, for instance, a 3 liter or a 3.2 liter 2J, and we're starting out with a much lower power output. Those things aren't actually very impressive NA, especially when guys run them at 8-to-1 compression, which is fairly common with guys running big turbo stuff. They just run 1,000,000 pounds of boost. And, as long as they have their tune right and can do that and have good intercooling, that's something that you can do, obviously. I myself like having maybe better power output on the NA side, and then we can achieve our power goal with less boost. But obviously, the guys that are drag racing these things are, they don't mind running 50 or 60 pounds of boost on some of these things. And if you get everything right, it can work fairly well. So I have some other examples that I'm going to do. I'm working on the video tonight on the back pressure and boost pressure and power output stuff and the correlation between those things. And I have some that are more usual, basically, when we have more back pressure and we have lower boost pressure, that it just makes less power. And that also can happen because the turbo is not sized correctly for the application. Now, Mike, thanks. Mike said that the graph showed up well. So I just want to make sure you guys could see that when I was showing it, because unfortunately, when I'm showing when I have the camera pointed at the screen, I can't see what it is showing unless I did dual screens here, which I could work out and probably figure out how to do, but I didn't do that for tonight. So that's interesting stuff. And there's a lot of detail stuff like this with turbos that guys don't have a full grasp on. Where guys run into this a lot is when they have to run class racing. So they tell you, okay, you can run this 76 millimeter turbo, and you can do, other than that, you basically can do whatever you want to the motor combination. And so then the choice becomes, do I pick a big motor and try to get power out of it? Do I pick a small motor and get power output? Is there an optimum size motor that's going to allow me to get everything out of that and then also we're with the drag racing, obviously you want the most average power during this run. So you also have to be considered or cognizant of the spool rate for launching the thing, because the leave obviously is very, very important, the 60-foot time, all of that stuff. So when they do class racing, there's an awful lot that goes into, and they obviously work with cam timing and head porting and all of that stuff to try to maximize what they're doing with that turbo for that application. And it's like running a restrictor plate motor, except the restrictor plate is the size of the turbo, either the hot side or the cold side, depending on which one they're getting to first. So it's an interesting thing when they're running that class racing. And I've had that conversation with Brian Tooley a lot, because they do a lot of that stuff. Obviously, if you can run 2 of those 76 millimeter turbos, then you run in a class where the turbos are unlimited. Then obviously your choices are much different and they're much broader, and you can make a lot more power. But the guys that are trying to squeeze everything out of that package, because a lot of times in these classes, they tend to limit the turbo guys more than they do the blower guys and the nitrous guys, because it's so easy to make power with these things. So the other thing I want to talk about is this book, this Turbo Era book. It's the original, the OG kind of turbo era of Formula One. A lot of cool stuff in there, including the fact that they at times allowed them to run as much as 4.5 bar of boost, which is, I think it's, what is that, 55 or 60 pounds or something? 65.25 pounds boost, which is all the boost basically. And the interesting thing, and again, because people, when we talk about, I get together with my buddies, my buddy Bernie, and we talk about these Formula One stuff. We talk about everyone talks about the big power outputs. You know, they bring up the fact that BMW used production motors. They used seasoned production motors because they figured that they found out that the blocks were stress normalized and they were much better at holding the power after they had been run rather than new blocks. And there's all sorts of wives' tales about what they did and how they did that. But basically, they just used blocks that were high mileage blocks and then remachined them for what they were doing with the turbo stuff. They did a lot of really cool stuff, including they did a lot of interesting stuff with fuel. I know the AGIP guys working with Ferrari, there's something in here, and I don't fully understand it because they didn't really go into great detail, but they're talking about the fuel that they were using to help bring charge temperatures down. They were surrounding what they said is the globule of fuel with surrounding a globule of water with a globule of fuel. And I don't know if they were talking about this at the molecular level or if they were just introducing water in there. But they did a lot of work on the fuels, and one was to get these turbo motors running properly and allow them to run the kind of boost that they were running. They were using intercooling. They were using water injection. They were using lots of cool stuff. They were using lots of boost, obviously. They were trying to do everything that they could to minimize turbo lag because they, as a driver, you want the thing to be responsive. It's a lot easier to drive at the limit if you have throttle response, because throttle is one of the ways that you balance the chassis. And if you have nothing there and then all of a sudden have everything there, like they said that the 917-30 turbo Porsches and Can-Am were like that. And they were saying that Donahue was one of the few guys that could drive it. I remember hearing a quote from Brian Redman. I know that this is a tangent, but that's really cool turbo stuff racing as well. He was saying the difference between him, and he was an amazing driver, and had lots of Porsche experience. He said the difference between what I was doing or other guys were doing and what Mark Donahue was doing is in this 917-30, which had lots and lots of power, is that we would go around the corner in the car, and then when we got everything straight, we would get back on the throttle. And he said Donahue would go around the corner, and before he got everything straight, he would get on the throttle in the hopes, or maybe the confidence, that everything would be okay on the other side. And he said it's that little bit was what made the difference between what he was doing and what the other guys were doing. And I thought that was an interesting take from another professional driver who, you know, drivers, if you know anything about them, are notorious for them being the best in the world. And it's great to have them recognize things that other guys could do or that they thought could do. It was kind of cool. But on the turbo era, they were experimenting with all kinds of different turbo sizing. And the thing is, what a lot of people don't realize is this was back in the 80s, started in the 70s. But there weren't a lot of turbos available. I mean, there's a good quote in here about when they first introduced the turbo stuff. And they said, and this is from Harvey Postlewaite. He was a chief designer for the Wolf team. And he said, we were there standing on the pit wall and watching the Cosworth V8s, the normally aspirated 3-liter Cosworth V8 Formula One cars, which were lots of them because they were customer motors that they sold to people or loaned to, they sold them to people. And we were watching them drone up the hill toward the pits at about 130 miles an hour. When suddenly the Renault, which was one of the first turbo motors to be introduced in Formula One, and then the Renault goes by and clocks 160 miles an hour, and then does it again and again. So it wasn't a one-off kind of thing. And he said, in retrospect, we all should have looked at that and thought, wow, that's a really big difference, even though the Renault at that time, because it was just more obviously than the 3-liter Cosworth stuff. But that much faster in terms of power potential. You ask a driver what they want. Every driver wants more power. A lot of great things. And the fact that they started out much closer to 500 horsepower and that eventually wound their way up to as much as 900 or 1,000 horsepower, depending on who you believe. And according to this book, he says in one of the statements in the book that he thought that the BMW motor was maybe the most powerful, but it never, in all the information that they're providing on BMW, it never talks about maximum power numbers. It talks about everything being a lot lower than most of the other stuff. The one that they talk about a lot is the Honda one that was running between 1,000 and 1,200 in qualifying trim. But again, the reality is that when you read into this, you realize that they were trying to limit the turbo cars by minimizing the amount of fuel. They allowed the Cosworth V8 guys to the naturally aspirated guys to have 30 or 40 gallons of fuel more, I think. It was quite a bit. Might have been liters. That sounds better. So they had a lot more fuel that they could carry, which means that they didn't have to stop. And then they stopped allowing them to do, because one of the things that the guys found out, and it probably was Ron Dennis or one of those guys, they figured out that, hey, we can do stops. Let's just start out with less fuel. We'll be a lot faster. And then we could come in for fuel and change tires and stuff. And so they introduced a lot of very cool things during this era. And then also they started doing the active aero stuff, which was very cool, and then the way that they were circulating the rules to do that. And one of the interesting things in the book was that they kind of led off with this at the beginning, is technically speaking, all of these wins by any turbocharged Formula One team or motor at the time was technically illegal, because what the rules said was the equivalency factor that they put in for the rules was that you could run at the time a 3-liter naturally aspirated motor or my mic, or a 1.5-liter supercharged motor. Now, everybody took that to, and nobody complained. Well, I don't say nobody. The naturally aspirated guys would eventually protest this fact and use that fact to try to protest the turbo guys, because there's no way that they could compete against the turbo motors. They were down by, I think that the Cosworth stuff was probably at the end was in the mid to high 500 range. So they were way down on power, but they were reliable, and they would last, and they would work, and they had more fuel. But technically speaking, these should have been, gear-driven or crank-driven superchargers, centrifugal blowers or positive displacement blowers, heaven forbid. Or like I said, one of the teams to try to get improved turbo response was working with a complex supercharging system to augment the turbo to get the response rate that they were looking for. And they also went into, they worked on anti-lag systems where they were introducing fuel and burning in the exhaust after the exhaust valve, between the exhaust valve and the turbo, to keep the turbo spooled up, and then they would stop that when they went back on the throttle. And so they were doing some fairly cool stuff. Obviously, and as I mentioned, one of the things I wanted to point out is that if you were able to run these turbos, most of them wouldn't run at the 1,000 horsepower flat out for a whole race anyways. Those were qualifying numbers, and they would last for a short period of time. But they would run at like I think that the Tag guys and certainly the Honda guys could run at 900 horsepower. The problem is you can't run at that power level and still make it available fuel. And the interesting thing is, especially early on, they didn't have fuel gauges, so the driver didn't know how much fuel he had left. And a lot of them didn't have tacks in them. So the driver didn't know, based on RPM, when he needed to shift. Because this was back when these weren't paddle shifted cars. These were shift cars. They actually shifted them, which makes it even cooler, because you actually had to do that. You had to have a clutch, and you had to have a transmission and all that stuff. And it wasn't all, gear selected and paddle shifted and all that stuff. Not to take anything away from Lewis Hamilton or anybody that's racing Formula One now, because they're amazing. But this was a different era, and this was different cool stuff. And so it's interesting to read through a lot of the things that they went through to try to improve this. And like I said, when when I read the quote from Postlethwaite, that he was saying how much more power the turbo guys had, and how it's fairly obvious on the straightaway that coming up this hill that they had a lot more trap speed. But the problem was, he said that it should have made all of us run down and put turbos on our motors. But the problem is, even if they wanted to do that, back then, they didn't have huge conglomerations running these teams with hundreds and hundreds or maybe thousands of guys to be able to make all that happen. They also didn't have, there weren't like excessive turbos everywhere that a guy could choose from, like hundreds and hundreds of different turbos that a guy could go, no, I want this one and this one and this one. They didn't have all that. It just wasn't there. BMW first did theirs and ran it with a naturally aspirated motor, and then borrowed turbos from some of the saloon racing, the 320 and 2002 turbo stuff that they were doing in the United States. So it wasn't, just Joe Schmo couldn't go down and design their own turbo and make that work. They were just introducing carbon composite stuff for tubs, and it's really interesting stuff. So if you want some cool like turbo information, and there are cool photos, you can see the different. You take a look at the different. See the exhaust manifolds. These are all little V6s. You can see the twin turbos. You can see the carbon fiber ducting to feed the turbo. You can see what the exhaust looks like. You can see the exhaust coming out of the wastegates and stuff. And you can see all the different types. Like if you look at the BMW 4-cylinder one, because they ran a 4-cylinder, where the other guys are running little V6s, and that they tried different angles for packaging. They tried different intake manifold designs. They tried the BMW, the exhaust on one of the BMW photos that they have is giant. It's super long. It's like a full length, turbo header exhaust manifold kind of thing. It's really interesting to see all the stuff that they tried. It's very, very cool. So let's see what you guys got going on. So Christopher Johnson said, according to Paul Roche, max observed power on a dyno was 1280. Race engines were about 800. Qualifying engines, yeah, they had qualifying engines that made a lot of power. Some of them, they even closed the wastegates on and then maximized the amount of water injection that they could put in there. They did some fairly cool stuff. Yeah, Kyle was talking about the toluene and heptane blend stuff. That's some of the things that they did, because the way that they were testing the fuel, they circumvented the test procedure because they were looking for something very specific. Well, they were able to make these fuels work with these high boost levels, even though it was only technically 102 octane. But because of the way that they were measuring it, they made sure that, and working with Shell and a Jeep and these guys, they were able to make the fuels do what they were supposed to do and pass tech, and be able to do what they did on the power side. Yeah, Randall, I've been to I raced at Road Atlanta and raced it at Road America, and I remember the closing speeds of some of the cars, because back when I ran World Challenge, we would run A, B, and C classes all at the same time. So you had some of these A-class cars that were probably, they actually had, back when we were running, some of those World Challenge cars had higher straightaway speeds than the Trans Am cars did, because they had, they didn't have the aero. They didn't have the wings and things that the Trans Am guys did. And because some of them honestly made more power. So it was pretty cool. But then you'd have those cars, like a Turbo Super or something that was making a ton of power. And then you had some of the, there was a Suzuki Swift that ran in the C class. And so you probably had 40 or 50 mile an hour closing speeds on some of these races. It was really cool. And I got to race Road Atlanta back when they had the gravity well, and we got to do it in the rain. So down at the bottom of the gravity well, and while we were driving, we had no windshield wipers on I had a little wipey stick. I had just a stick, I think we taped a sock on it or something, so that at least I could wipe out the fog on the inside, because we had no blowers or heaters or any of that stuff. Hector, can you comment on the sloppy stage 2 really quick? Just got it. And I was hectic about what is it you wanted me to ask about the sloppy, or what did you want me to say about the sloppy stage 2? Can you recommend any vendors for a 265 small block build? How much power do you want to make? Is it a really high dollar one, or is it just a standard rebuild? Yes, grand, 1.5 liters. That's pretty small. So Tom, you lost your 300ZX. Those were T-top cars, right? Yeah. Rex is in the house. Needed a motor for my van. Want a high mile per gallon, 4.9 straight 6 with a turbo or a 302. I don't think you'll see much of a difference between those two. And a van's going to be fairly heavy. Matt, what's up? I saw your video on it, and it seems to be a very well-rounded cam. What did you do with nitrous? The camshaft does what the camshaft does on your combination. Anything that you add to that just adds to that. Whether it's nitrous, whether it's a turbo, whether it's a blower, the cam just does what the cam does. The cam isn't good with nitrous. It isn't good with boost. It isn't. Well, it is good with nitrous. It is good with boost. And it is good with a blower. It works with all of those, and it works fine. That's not anywhere near my favorite cam, but it's cheap and it works. What's your opinion on drawing water through 4 corners temp kit? Keep cylinder head temps cool. Are you talking about the factory connection that they run that connects all of those? Most guys run those. We don't normally run them on the engine dyno. A lot of the heads are plugged from the back anyway. We run a crossover on the front, but we cap it. We just use it to get the air bubble out and then cap it. We probably should run it and let it circulate, but we don't. Well, Tom, if you want a turbo, an Astrovan or a Safari van, you should, and I don't even know if you'll find any, but you need one of the old turbo caravans. I have a cam question for you. Thinking back to that little 342 Dart motor you built, I changed the cam out to a 248 256. So that's not really a street cam, but it should make power. Make sure that thing had enough. That thing had enough valve relief. So 106 LSA is pretty tight. So maybe just take a look at piston to valve clearance. Spraying a fine mist of water at the turbo inlet keeps the intake temperatures and turbo temps cool without an intercooler. No, I mean, it'll help. It's water injection basically, and that will help. I don't like spraying the water before the turbo because I think it's bad for the impeller. Even if it's a fine mist, it's still bad for the impeller. But it will cool it better than not having anything, but it won't cool it as well as an intercooler does. Small block Chevy 265 rebuild for a stoplight hero, medium budget. If you're trying to do a stoplight thing, you should build a bigger motor than that. If you're and that's fantastic. If you want the 265 and that's your thing, that's okay too. The problem is you're not going to have a lot of head choices for that, but it's a small block Chevy, so you can put a cam in it, put a dual plane on it, put a carburetor on it, maybe port those heads. So it's a solid roller, Matt. So you're wanting to build a race motor then? And if you want to make torque with the 265, you could always add boost. Best cheap cam for a turbo 5.3 for 500 wheel horsepower. Keep a decent idle. Well, for 500 wheel horsepower, you don't even need a cam. You can just run the stock cam. And I want an S4. If you're only trying to get 500 wheel horsepower, I wouldn't recommend the S475. I would recommend something smaller than that. It'll be more responsive. And you could do that with a stock cam. I think it's methanol. I'm not talking about contaminating them. I'm talking about any sort of semi-solid object hitting an impeller at speed. The impellers are designed to only flow air and not have other things hit them. Is it necessary to run a vacuum pump on a street strip big block Procharge motor? The vacuum pump is going to be more a function of how much camshaft you have in that thing. Have you messed with a TIC Performance Stage 4 cam? I've never run one of those. The 4-corner steam kit, I figured it was a water line connected to the kit to the pump for extra water to cool down. I think the water's actually coming out of that and not going into it. If I'm correct, somebody correct me if I'm wrong on that. Straining TV, thank you very much. Have you ever had a shop rag get sucked in? Matt's question is, have you ever had a shop rag get sucked into a turbo or supercharger? And the answer is, and he already knows that this is yes. When we were at West Tech, we were running a motor with, I think it was Mahovitz. And there was a table where we have all the parts and stuff on them for things that we're swapping out. And he was running a Vortec on something, probably, I'm sure it was a mod motor. And there was one of the red shop rags, and it was sitting on the table. And so they started the motor up after doing whatever they were, tightening clamps or whatever they were doing. We'd go back into the control room, and they start the motor up and load into it. And I think Brule was running the dyno. I was just there. And Mahovitz was there running this motor. And they load it at whatever RPM and then release it, and it starts going. And then you see the shop rag sitting on the table, starts going, woo, phew, and it just takes off and goes right into gets sucked right into the blower and locks up the impeller and breaks the blower and does all kinds of things. So I don't recommend that. I recommend you not having stuff that's opened up. Strain, what are you doing? I recommend you not having things opened up like that with a shop rag nearby, because it will definitely go in. Adam says, can't wait to see turbos run on the Magnum. Strain, what are you stepping up your game here? $199, $299, $399. Rex is in the game. Where are all the rest of you? Why are you letting them take all the credit? I sucked a red rag into my 300ZX intake. That's probably not good. Strain, what are you doing? You're just spending money left and right. Rag sucking story beats mine. It was really funny, and it was very cool to see it, like, because it was basically like someone using mind control, because it just kind of, like in the movies, it started to levitate itself a little bit, and then as soon as it got free and clear of its grip on its gravitational grip on the table, then it just like was, okay, I'm exiting stage left here. Yep, it's definitely the item to count. We left one under our air cleaner on our World Challenge car because we wanted to cover the carburetor to be safe, except that we stuck the air cleaner back on it and the car would start up. And this is when we were ready to go out onto the grid to go race. And we'd start the car up and it would start and then it would immediately die and it wouldn't take throttle. I'm like, oh man, really? Right now, this is when this is going to happen? And then we realized it and fixed it. When would I know it's time to run a vacuum pump on a motor? Well, what kind of vacuum do you have, and what kind of vacuum do you need for your power brakes? Joseph, my first actual live chat. Welcome. Strain, dude, what are you doing? Wait for it. Wait for it. Yeah, the target of lifters and fire stuff. Yeah, I have lit stuff on fire. I've leaned over when we're working on a motor and it's on the dyno. You lean over, and especially a lot of the big blocks and small blocks that they run at West Tech have what I call what are those things? Sprint car headers. So they come straight out from the head and then down and then back. And so you can get access to everything. It's kind of nice, except they're in the way. So if you try to lean over and get to the carburetor or the intake manifold, you catch everything down here in this lower region on fire, and it's not good. Yeah, frozen poultry into the jet engines. I like this. I like when they do the jet engine testing. I also like when they do the jet engine testing on the thrust side too, on the exit side, and see what, like, if you can blow over a station wagon and all of that. Let's see. The GT45 would work okay on a stock 4.6 or 2 valve. You want something bigger. Yeah, probably something bigger than that, than a single on one of those. Do you think that the dyno accurately represents what you would see on the street? People have always said big ports equals poor performance under light throttle at your chest. All we do is run under at wide open throttle. We don't do part throttle stuff. So I suspect that big ports may have different results at part throttle than they do at wide open throttle. I think that common sense says that they would be less responsive at part throttle. But again, I don't know that for sure because I haven't really tested it. I know, Mike, the likes are 50%. Come on, we can do better than that. Yeah, Henry, are you talking about crankcase? Are you trying to get vacuum out of the crankcase? Do you have like light ring package and stuff? Devin, here's an interesting topic: turbo wheel size versus AR ratio of the housing. This is something guys typically don't consider and can allow big turbos more response, as well as small turbos more room. Yeah, because the AR is a function of those things. It's not just an absolute number. Have you guys ever split any 5-liter Windsor blocks? Curious how much power with a good tune. I've only been involved in one that split, and it was the guys from HP Performance, and that's when we ran a test where we ran their turbo kit on a stock one and ran it at the drag strip, and then did an upgrade on it. We did heads, cam, and intake, and showed what it did NA, and then also what it did under boost, and then ran it again at the drag strip under boost with the upgrades to it, and then it split the block. Strain, I appreciate all that you're doing. It's awesome. What do you think about the Holley EFI kits? We run the Holley HP EFI stuff on the engine dyno all the time. That's one of the few things that I test with. Are we supposed to talk 80s F1 turbo? We already did. Where were you when I was talking about this, Matt? Did you see this book? I was going over everything in the book. Vacuum pumps or drag race. Strain has a stolen credit card. Here's an interesting topic. Okay, we did that. I know I'll need some help when it comes to tune, fuel injection, and computer tuning. Yeah, I've lit stuff on fire, welding also, Tim, all kinds of things. The best thing is when you spray brake cleaner or something on a rag and then light that on fire, and then it doesn't ever want to go out. I also had somebody try to put out a fire, an engine fire that we had with a nylon jacket, and that doesn't work out very well either. The RPM levels on the Formula One cars were not that high. They were, I think, 12,000. And they eventually regulated them down to 2.5 bar of boost and 150 liter fuel capacity and a 540 kilogram minimum weight limit. Although one of the interesting things I read in here was that they also allowed them to put water into containers on the cars to run brake cooling. So they could run water-cooled brakes. Except that according to the information in here, a lot of that water didn't find its way into the brakes, found its way into the motor. And they also allowed them to refill those water containers before weighing them at the end of the race. So it was interesting. And if you take a look at this and go through this, it looks like as they went to more and more efficient stuff, where they were more concerned with fuel mileage, they tended to go with, it looks like, and I need to write all this down to be sure I know what I'm talking about, is that it looked like they started increasing the stroke on these as they did that, which I thought was interesting. And I also like the fact that the last year of the turbo era, before, at the very beginning of the year, when they said, okay, now that we had limited these turbo cars to 2.5 bar and to 150 liter fuel capacity and running a higher maximum 40 more kilos than the naturally aspirated motors, one of the FISA president, Jean-Marie Balestri, he was speaking at the meeting in late 1986. He said that, I promise you, gentlemen, in 1988, no way for the turbos. They will not win another race. 1988, the McLaren Hondas won 15 out of the 16 races in their turbo, their turbo motors. So be careful what you say, because that's awesome stuff. Let's see. Question: how much effect does the downstream O2 sensor have on tuning, or does the upstream do? I think that the O2, I think that second O2 is less for tuning and more of telling you whether the cat's working, right? Where can we buy the book, and how do we order a custom autograph first edition? This was through Auto Course. I think I probably got this through Amazon or somewhere. Yeah, having fuel go all over and having it catch on fire is not good. Trust me, I know. Yeah, and that's one of the things that, as a matter of fact, I think it was, I'm trying to remember who it was that they, I think it was Ken Tyrrell. In this book, he was running a Cosworth, and he protested one of the turbo teams for this water container because it had lead in it. It had lead, what they were saying was lead ballast. But they also wanted to check and make sure that there was nothing funny about what was going on with the water content, to see if they were getting extra, power enrichment or something anti-detonant or anything like that other than just the water itself. So he protested that. Coincidentally, he was one of the guys that was also, they needed a unanimous vote to allow the turbo stuff to continue, and he was not going to do that. So they kicked him out for maybe 2 races, I think, and then had the vote, and then he wasn't there, and so they got the thing that they wanted. So it's very, very political. Strain TV, if you had a 5.3 LM4 aluminum block stock, what would you do? Push it to the limit, and would it be? I think that the LM4 is a is that like the L33? If it is, then 700 wheel horsepower wouldn't be a problem at all. anything over 500 horsepower, the 5-liter windshield block will split. We know that that's not true. I've run it a lot higher than that. Why can't I put an O2 sensor on each exhaust runner if I'm turbocharged? Do they not work correctly under boost? They do work fine. The problem is that the temperature between the exhaust and the turbo gets very high. A lot of the O2 sensors won't take that temperature for very long. Yes, 6-wheel Ken Tyrrell. Yeah, that was an amazing car. Yeah, he got booted. Yeah, the 5.3 aluminum blocks are very strong. The L33 stuff and the LC9 is the ones that we always use as an example. I'm not as familiar with the LM4, but if that's the case, they're very strong. And 700 wheel horsepower is not a problem at all. That's just a cam and springs and boost, and you're away you go. Bob, I was on vacation for a week. The LM4 is basically an LM7, just an L33 block. Okay. Yeah, so if it has that block, you're golden. And is the LM4, is it a Gen 4 motor or is it a Gen 3? Yeah, Exmo. I've caught firewall grinding stuff too. You just don't pay attention to all of those sparks. Look, there's a whole bunch of them. They keep going in the same place, and all of a sudden, that same place lights on fire. How much displacement can get out of a stock 351M block? We know that will go to 400, and I think we normally go 30 over on those. LC9 is a Gen 4. Yeah, detonation can kill any block or any piston or any crank. Doesn't matter whether it's forged or not. Yeah, Mike, those blocks will definitely split with hard shots of nitrous, especially if they if they have too much timing. Yeah, so you can, with the LM4, you can make lots of power. We normally use the iron blocks only because, for me, when we go to the wrecking yard, that's what I find. I find all of they're either going to be, whenever I walk around, there's going to be an 862 headed version or a 706 headed version. That means those are either 5.3s or 4.8s, and typically they're LM7s or LR4s. Because I don't see nearly as many Gen 4 stuff motors as I see Gen 3 stuff. So normally what we get is is an LM7. But as we've seen, it makes fine power. Phil, 5.3 LH6 has 799 heads, getting 2 eBay GT45s. Want to drive it at about 700 horsepower, but want to be able to go to 1200. What cam? It depends on how much time you're going to spend with each one of those. The GT45s will easily do 1200. You can run, I like running smaller cams, so I would run on a 5.3, I would run like a stage 1, maybe a stage 2 turbo kind of cam or NA cam. Kind of feeling bad for going an iron 6-liter over an aluminum 3. Both of those work, and the 6-liter makes more power than the 5.3 does, but it depends on how much power you want. With a 6.0, you're starting with more, so the thing is going to be more responsive and all that. Straight TV's going nuts here. Paul, the headless motors were not part of this. They weren't part of that turbo era, at least not that I saw. So, Mike, you're saying the block split, the balancer when it's running. I have seen people break the snouts off of cranks on 5 liters back when we were running blower stuff, when they would just reef on the tensioner on the blowers on the vortex and stuff. Then, you know, it's just hard on stuff. I've seen them wear out the front main bearing also because they're putting so much load on it. Can I put a Procharge on a motor that has more than 8.5 compression? Yeah, you could do 9.5, 10.5, all of that works. When do you need forged internals? It depends on how much power you're making, and you got to tell me what kind of motor that is. If it's an LS motor, obviously we've run stock internals up to 1,500 horsepower. So if you need less than that, you might not need it. All this LS talk, got the small block Ford guy here second guessing himself. I like small block Fords. I like Nash Metropolitans. I like all of them. They're all good. The stock 5-liter crank is junk. I've never, well, we broke that one with the guys from HP Performance, but I've never broke one on the dyno. What's your opinion on compression ratio for a small block 383 4-speed manual going in a 69 K20 on 35s? Are you going to be running it on, if you're running on pump gas, then I would make it like 10-to-1 or less. What kind of exhaust temps do you have to be running to make the manifold glow red hot? Not very much. You just have to do it for a fair period of time. Strain TV, you're going to have to send me your address, man. I'm obviously going to have to send you one of these shirts. .444 stroker by T. Meyer. Yeah, he does a lot of stuff for those 400, 351Ms and 400s. I've cracked small block Chevy balancers with blowers. Snouts are too short. And I've seen them spin on there too. That's why they do the dual keyway on them. Could you put a little T25 Garrett on a small block Ford V8 as twins? Yeah, the T25s are kind of small for a small block V8, depending on what the original power output was. Does higher compression work good for 4x4s that need more low-end torque? The higher the compression you have, the more low-speed power you'll have, but you also have to worry about, you start getting into a point where if you have the available octane, you can't run enough timing, and then you have to take timing away because it's going to detonate, so you lose some of that. So you lose some of that torque. I want to turbo a Ramjet 350. What engine management system can I use? And the harness, you could use a Holley HP like we do, or probably even the Holley, the Terminator X or whatever. You probably could use that as well. And they have generic harnesses. All you have to have for that motor is it has fuel injectors, so it doesn't. The computer doesn't care that it's a Ramjet or doesn't care that it's a Ford or Chevy. It doesn't matter. It just hooks up to the distributor and gets a signal, and it powers the injectors. All of that works out just fine. We run our universal harness for the Holley on a Ford and Chevy and Dodge. It doesn't matter. It's not pointless. It's just, David, you have to, and the other thing is a four-wheel drive is going to be heavy, so you have to make sure that the detonation is always the thing. That otherwise guys would be just running 15-to-1 compression all the time. But you can't because of the available octane. Nobody wants to put, C16 and drive around their car on gas that might cost $10 or $20 a gallon. People don't want to do that. If you're running E85, you can run more compression. You could get more low-speed power. You could get a little bit of power from the E85 itself if you wanted to do that. Otherwise, you have to have a reasonable amount of compression. and then you have you're able to run it on pump gas, and then you can use a dual plane intake if it's carbureted, put the right heads on it, and you can get the low speed power that you want. Team America 5.3 Pro LS sloppy stage 2 big long tube intake, 145-pound injectors and a 4L80 to put the power down. My Holly Terminator T88 turbo. So that's the turbo is gonna dictate how much power you run. That motor, depending on, I don't see what heads are on that, but let's assume that the motor makes, I don't know, 450, something like that, 460. And then you just start multiplying that times the boost you want to run on that T88 because it'll support a lot. 11-to-1 board 30 over. Are you're running it on E85 then, I assume? Oh, a Samurai. Samurai's good. So the lighter the vehicle, the more static compression, but 10-to-1 should be fine. The dog, that's my dog's 2 golden retrievers. Richard, I'm curious, who do you work for? I saw where you work for West Tech. I don't work for West Tech. And I started out working as for the magazines long ago, but this is the only thing that I do now are these 2 videos. .862 with 2-inch intake. Oh, a 2-inch intake valve. I see. Okay. Did I miss that on there? Or did you put that on there? Sloppy stage 2 cam, big long tube. GT Mustang with a 255 V8. Yes, all the power. Oh, very cool, Tom. Yeah, we have a and a girl. They're not puppies though. Long time, and they are the best dogs ever. Yes, I am independent. I don't work for West Tech. I don't work for the magazines. I don't have a job for anybody. Variable Venturi carburetor, best carburetor ever made. Jeep 3.8 is gutless. Have you ever tried piggyback tuning to run a turbo? I've never run the Jeep stuff, so I don't know about the ECU on that. You know, given what we did back in the day with 5-liter Mustangs with FMUs and turning the distributor or a boost retard setup for the distributor, if you can do that, as long as you can take timing away and add fuel and tune that, you can make it work. There was an early 80s Mustang with a turbo 4-cylinder. Yep. Henry, how much compression was on that 496 Procharger video you did? I think it was around 10-to-1. We normally put on the 496, we normally would put around an 18cc dome piston in there, and I think that's what we did. Predator carburetors. I've never run a Predator carburetor. I don't know if Brule has either at West Tech. I only remember reading about them in Hot Rod and stuff. Okay, only got a couple minutes left. I remember the piggyback stuff. A lot of the turbo stuff, the HKS stuff was all of that was piggyback stuff. And also the additional injector controllers and things. They did some of that with Vortec kits on the throttle body injected motors too, because they just couldn't get enough fuel. Yeah, the Bigfoot had Predators on it. Variable vane testing. I would need to find variable vane turbos and then a way to control them. Jeffrey, if you say his question is, can you explain functionality of using vacuum canisters, distributors on boost to control ignition timing? If you take a look, like my Sprint turbo, best car ever, had vacuum advance and boost retard. It had 2 pods on it, so it had lines going to both of them, and so it would move the advance and retard mechanism on the distributor based on which arm it had coming out of which pod. So it turned the distributor that way or that way, and it worked really well. But that was a factory deal. What we did before was we would use the ignition amplifiers, like from Crane or MSD, on the distributors, and then they had a vacuum reference going to them, and then you could adjust it with a dial on how much boost or how much timing you wanted to retard per pound of boost. So I think it went up to 4, because I think a guy doing more than retarding 4 degrees of timing per pound of boost gets to be ridiculous, because pretty soon you don't have any timing in the motor if you have any boost. So you could take out a 0.5 degree or 1 degree or whatever, and then you would just tune that based on what your octane was and whether you had detonation and stuff. But also as an ignition amplifier, so that you could get better spark energy if you needed that, which we do, and especially before we were bringing our plug gaps down. So you needed to do that, and then you could retard the timing that way and then add additional fuel. One way that we did it back in the day was with an FMU. You're basically just clamping the return line down on the fuel system, and so it raises the fuel pressure. The problem with that is it makes life very, very difficult on the fuel pump. So if you only have 155 liter per hour fuel pump and you're asking it to flow that with 100 psi of fuel pressure, the flow rate of the pump goes way down. So using an FMU, you also have to have a lot of fuel pump in order to do that. Or the other way to do it is put bigger injectors in, like we did back in the day on the 5-liter Mustangs. We matched the big injector to the big meter. So we get a Pro-M meter for 24, 30, 36 pound injectors, and then put the injectors in, and then it would be very, very close. Yeah, unless you're wanting to do something specific with the let's see, a 10 psi twin GT5 twin setup would be fine, right? The reason I ask is twin T25s are everywhere, junkyards and VW diesels, 2.5s. I'm talking a budget build. If you want to do a budget build, you can. T25s are not going to support a lot of power. They might not support 10 pounds on whatever you're putting it on. I don't know what you're putting it on. I didn't read that far back. Ooh, Starion turbos. I like those. There's not a lot of power potential on a 255 Windsor. It wasn't a great motor to start with. It's really small and doesn't have good heads on it. Tom, I've mentioned that a bunch. Favorite car. I wish I never got rid of the Sprint, because I wish I still had that. Also, the Ford GT I had. I had a tri-power Corvette, which I wish I wouldn't have gotten rid of. I wish I would have kept a lot of those. Any info on the Chevy 366? Are you talking about the big block 366, the truck motor, the tall deck stuff? Yeah, we look for 351 roller blocks in the later stuff. I think it's 94 and up. What do you think we would see if we put a diesel turbo on a gas engine? It works fine. We've run diesel turbos on gas engines a lot. That's where we would go get them, was from the trucks. We've run a lot of whole set stuff. The 5-liter shares similarities with the 351. It shares the same head. It doesn't use the same intake because the deck height's different. It doesn't share the same crank. It shares the same camshaft. It shares the same lifters. And that's about it. Oh, 366T? I thought he was talking about a 366 big block Chevy. A 366 turbo is also a good turbo. What do you think about the Anderson N41 cam for a Ford 302? That works good. Subaru boxer motors. I was just talking to my buddy Gary Sheehan about that because he's raced quite a few of those, and they're good. I've never built one, so I can't talk specifically about them. I've driven them, and I liked it, and it made lots of power, but I don't know anything about the internals on them. What are your thoughts on Japanese V8 motors becoming collectors in the near future? I don't know about the V8 stuff. I know if you've ever taken a look at the pricing on an Acura NSX, a 3rd gen RX-7, I don't know if the Dodge Stealth and the VR4 have the same, but maybe the Nissan Zs, but certainly the Acura and the 3rd gen and a Supra, all of those are big collectors, but I don't know about the V8 stuff. The whole set that we were running was not OEM for a Ford truck. The one that we were running, I think, was from a big rig. T25 on a 4.62 valve. What's the smallest turbo you can run on a 4.6 as a single turbo? How much power are you wanting to make, Clint? You look at a GT3582, although I think even that's like a 500 horsepower turbo. So I think that's going to be like super responsive and super back pressure-y. I think you'd want to run something a little bit bigger than that. Wondering if big block accessories work. I've never seen. I've only looked under the hood of one tall deck big block like work truck that I can remember, and I think it was a 427. But I didn't pay attention to the big block accessories. No diesel turbos. I mean, I don't have videos. If you look at some of the turbo stuff that I've done on the Fords, on the 5-liter set turbos that they supplied with their kits. Sinister Silverado, that seems like a good project. Swapping the 4.3 out for a 5.3, that's good. Yeah, SR20s are insanely priced as well. And look at a 510 or in any of those. Recommendations about the 210 Pro Comp heads. You need to look out for everything. You need to look at the seats. You need to look at the valves. You need to look at the springs. You need to look at all that. The RB25 is getting valuable. I have one of those. Yeah, the 3000 GT VR4s are cool. They're very technical, especially at the time. I have a 350 Vortec with a single GT45 turbo. Do you think my cam is right or too much overlap? Specs are 480, 230, 230, and a 109. That's not an ideal cam, but like I said, it will work. It will make boost. I wouldn't use a single pattern cam, and I wouldn't use that tight of an LSA on a turbo motor. But you can run boost on that. So the 366 was less than a 4-inch bore. Wow. The GMLS is the cheapest of all of those to work on, Matthew, if that's what you're asking. But they all were the modular V8 would be my last choice, just because there's not a lot of aftermarket support for that. There's not a lot of aftermarket heads and stuff. There are for the LS, and there is also for the Hemi. And I also like the Hemi in that the factory heads are really good, especially the later ones. The 3000 GTs are fairly heavy, yes. Sean, I sent you an email today about sponsor for a fuel test. Yeah, I did get that. Lane, have you ever tested a supercharged 3800 series V6? Yes. If you take a look, I think I have 1 or 2 videos up on that, and we have another one that I'm doing a bunch of testing on. Yeah, the big blocks did have 4-ring pistons. Does a 351 come with better flowing heads than the 302? No, they don't. You should get aftermarket heads or get the GT40 heads from the Explorer. What is your opinion on whole set turbos for 4-cylinders? You just need to size the turbo right for your 4-cylinder. Jake, I don't know about the distributor question on the 98. Yeah, Matt, if you look at the EcoBoost stuff or the EcoTech stuff, if you look at what they did with those when they were racing them, they've made millions of horsepower out of those. I don't know about the EcoBoost. I would suspect that they have. I mean, I think that that's the version that they ran at Le Mans, so they did fairly well with the Ford GT stuff. But the Chevy EcoTech stuff, they made a lot of power with those in sport compact racing. I think that the Roush guys were in the 13 or 1400 horsepower range. The GT40 heads are the name that they put to that. It's an iron head that they use that Ford sold through Ford Racing, but they also use them on some of the performance applications from the factory. The point being, and the way that most people get them is they come from the Ford Explorer, and they have GT40P and regular GT40 heads, which there's a difference in the exhaust port location or something that's going on with the exhaust port, if I remember right. The Big Bang 351, I need to revisit that. Tim, that's what I was thinking, that I don't think you just turn the distributor on those things anymore. Not like we were doing with the 5-liter stuff back in the day. What fuel do you prefer when making the most power? We would run 118 Rocket brand stuff back when we were doing it, but C16 or something like that. I choose that over E85, maybe because I don't know any better. But I like the higher octane of the C16 when we're really turning the boost up. What's the relationship to power between exhaust velocity and background? I'm not sure how to measure exhaust velocity. Do you have a little velocity wheel in there to tell you the speed of the air? Is that what you're looking at? Yeah, the GT40 heads were also used on the Cobras, but it's easiest to find them on the Explorers. Jake, I think it will. That's what we're saying. I would think if you move the distributor that it will not like it. A couple of decent SR20s would pull a premium 1 week before race wars. That's true. Only if they have spoon engines in them. Have you Googled and read the Battle of the Titans yet? No, I haven't. Yeah, the plug angle is weird for on the Gt40 heads for plug wire access and plug access. A 4-valve head makes more power than a 2-valve head. If you're talking about ultimate, if you look at what any form of professional racing, just look at the top of that and see what they're running. If you look at a Formula One motor, it's a 4-valve head. It's not a 2-valve head. My Gt40 head's flowing like 5 pounds of boost, pushed my stock block to its limits. I probably not. That's probably something else because we've run a lot more boost than that. Have you seen videos of Big Dog porting Tony B? I have not. I'm not familiar with that. How come the L7's heads have a 4-digit ID? Some of them do, and I think some of the LS3 heads also do. Can anybody recommend any books or videos on engine tuning? 351 Windsor versus the Vortec 350 versus the Magnum is the one that you're looking for, is the other one that we want to test, that we want to compare. They have tried 5-valve heads, but I don't know if 6-valve heads have been tried. I don't know that I think that they found that there's diminishing returns. Gerald, thank you very much. I think I think Ferrari had 5-valve heads on some of their production stuff, if I remember right. I would like to see an LS7 with adapters and a Recport truck manifold. That'd be a super sneaky setup. Can you adapt the LS3 to the LS7? I don't know if I've seen those adapters. I didn't recommend a book on tuning. I asked if anybody else had recommended one. I was looking to see if anybody did. I'm going to take a look and see. Let's see. This is from Engine Labs, from Greg. Yeah, Ferrari is probably best well known for the line of 5-valve engines, including the 355, 360, and a 4.55 liter V12. So yeah, they had 5-valve production engines as well. 4AGE Silvertop, I do like those. Yeah, lots of guys ran them. I just don't know that they got anything out of them more than a 4-valve couldn't do. But I got to get going. Corky Bell. Let's see my various books. Corky Bell has good stuff on turbo stuff if you want to learn kind of generic turbo stuff. Okay, guys, I got to get going. Thank you all for showing up. I will be back tomorrow, and I'll put the video up on the comparison between the 317 and LS3, although it's not typically about that. It's more about the relationship between boost pressure and back pressure and power output and how we look at all that stuff. It's pretty cool stuff. Thank you guys for all for showing up, and I will see you tomorrow.